So I want to determine whether or not this sequence here, this sequence defined by this rational expression, converges, and if it does, to what value. So to answer this, I need to take the limit of that nth term expression as n goes to infinity and see what happens. Now, we actually looked at one similar to this in another example, and we were able to split it up into multiple fractions and kind of evaluate each term separately. Now, we're not going to be able to do that here because there's two terms in the denominator, not just one. Right? So what we're going to do is I'm going to say, look, if I define a function, f of x equal to 4x cubed plus x minus 2 over 3x cubed minus 4, then if I evaluate this at n, that gives me the nth term of the sequence. That's one of the theorems we talked about in the lecture, says that because I could create this function, this limit is equal to the limit as x goes to infinity of 4x cubed plus x minus 2 over 3x cubed minus 4. And this is something that we know how to evaluate. You can use L'Hopital's rule. You could divide the numerator and the denominator by x cubed. Or you could just remember the rule. It says when we have the limit of a rational function and the degree of the numerator is the same as the degree of the denominator, which is what we have here, they're both 3, then the limit is just the ratio of their leading coefficients. So the limit here is going to be 4/3.